Okay, in this video we will explain a very nice relation that we have between algebra and geometry. Something algebraic is something like this equation, x squared minus 4 equals 0. And something geometrical is like a real line. Then to construct a real line we need to decide a point to be number 0. We decide a point to be number 1, and once we have 0 and 1, we have every other point. Then if we think about this equation, its solution is x equal 2 and x equal negative 2. Then this algebraic equation is represented by this pair of points. This is if we have only one variable. When we have two variables, let's say the equation y minus x squared equals 0. If we are thinking about two variables, then we have the Cartesian plane, x and y. And when we think about every possible number that satisfies this equation, for example, 1, 1, that means x equal 1 and y equal 1 is a solution. 1, 1 is a solution. We can see that x equals 0 and y equals 0 is a solution. But when we try to test every possible point and highlight those that satisfies the equation, we will see that we will get something that is called a parabola. In general, if you are feeling very romantic and you want to draw something like a heart, then you can see that it is possible to find an equation, an expression in terms of x and y equals 0, an equation that represents this heart. Any possible shape that you can think, it can be represented by an equation. We also are going to be talking about a system of equations. Then, for example, we can think about these points that satisfy this equation and points that satisfies this equation. Usually, in this case, we have that this represents a curve, and this also represents a curve. In this case, this curve, you can check that it is given by a line. Then in this case, the solution of this system are just these 2 points. When we have something like x squared plus y squared plus z squared equal 1, if we have 3 variables, then we need this space to represent the geometry that comes with this algebraic equation. We have x, y, and z, and if we try to draw all the points that satisfies this equation, let me show you some. For example, 1, 0, 0, or negative 1, 0, 0. Another point would be 1 over the square root of 2, 1 over the square root of 2, 0. And you can see that there are infinitely many points, and when you decide to plot all those points that satisfy the equation, you will see that you will get something that you will get a sphere of radius 1. You can think about the intersection of, if you think about a system of equations, then let's say points that satisfies this and points that satisfies this equation, c equals 0. What point satisfies this equation and this equation? C equals 0. Here, notice that even though we see only one variable, z, but we are thinking that x, y, and z are involved, then in this case, one possibility is like 3, 17, and 0. That means x equals 3, y equals 17, and z equals 0. This is a possible solution. And when you think about all the possible solutions of this equation, you see that the points are x can be anything, y can be anything, but z must be 0. That means that that intersection is the plane, the xy plane. Then what point satisfies both equations? Then they must satisfy that x squared plus y squared equal 1, and then we see that the solution of this system geometrically, it has to do with a circle of radius 1. Again, if we have something in the space and that it looks like this, you can build a pair of equations that represent this curve that you started with. There is an equivalence between geometry and algebra. Notice that in general, not every system has a solution. For example, if I think about this equation and this equation, c equal 1, what is the solution of this equation, c equal 1? It means that x can be anything, y can be anything, but c has to be equal 1. Then, in this case, this is a plane. This is the plane that is parallel to the xy plane, and is this plane here. Right? The intersection of this, there is only one point that satisfies both equations, and that point is the point 0, 0, 1. X equals 0, y equals 0, c equals 1. When I have c equals 0, I have infinitely many points. Now when I do c equal 1, I only have 1 point. What about if I think about c equal 2? Geometrically, it will be the intersection of this sphere with the plane c equal 2. The plane c equal 2 is a plane parallel to the xy plane that goes through this point 0, 0, 2. And we can see that there is no intersection. That means that there is no solution for this. We can easily see this. If c equal 2, then we have x squared plus y squared plus 4 equal 1, which is impossible. 2 squared is 4 equal 1. This is never possible. And then the point, again, there is a relation between algebra and geometry. Then we're going to be talking mostly about algebra, and we're going to be talking about systems of equations, but the equations that we're going to be dealing with, they are going to be called linear. That means that something like this is not going to be allowed, or something like this. Let me just give the definition. First, we're going to be dealing with, let's say, n variables. We're going to be having n variables. And I was using x, y, and z for 3 variables, x and y for 2 variables. But in general, for n variables, I'm going to think about x1, x2, up to xn. And we're going to say that a linear system of equations is a collection of equations that can be written in this form, like a11 x1 plus a12 x2 plus a1n xn equal to b1 a21 x1 plus a22 x2 plus a2n xn equal b2, and so on until x a m1 x1 plus a m2 x2 plus a mn xn equal to bm. Then we have m equations with n variables. Some examples. Then if we have like 2x1 equal to 3x2 minus 4 and x2 equal 5. Then in order to follow exactly the definition and see that this is linear, I should write it like 2x1 minus 3x2 equal negative 4. And here 0x1 plus x2 equal 5. And then we see that in this case n is equal to m is equal to a11 is 2, a12 is negative 3, b1 is negative 4, a21 is 0, and a22 is 1, and b2 is 5. Then this is a general definition, and just to finish with something, I would like to emphasize that we are very, very familiar with this type of when you have two equations with two variables. Geometrically, they represent each equation represents a line, and then geometrically we have that the solution is the intersection of the two lines if we have an intersection. But let's see what happens in general for a 2x2 system, and we're going to use the geometrical aspect of it. We may have, what possibilities do we have? We may have that a system like this, like 2x1 minus x2 equal 1, and 4x1 minus 2x2 equal 2. Geometrically, what is happening with this system? Let's see what happened here. When x1 is 0, x2 is negative 1, and when x2 is 0, x1 is 1/2. Right here, this is 1, and this is 1/2. Then we have this line. Here, for this line, if I make x1 equal 0, then x2 is negative 1, and if x2 is 0, then x1 is equal to 1/2. We notice that both of the equations are the same. That means that in this case we have infinitely many solutions. What happens if we have a system like this, like x1 plus x2 equal 1, and x1 minus x2 equals 0? Then in this case, geometrically, we have that this line is a line that goes like this. This is 1, and this is 1. And this line is a line that goes like that, x1 equal x2, and we see that the only solution is the point 1/2, 1/2. And actually we may have something like this case, like 2x1 minus x2 equal 1, and 2x1 minus x2 equals 0. When we think about this line is the same line as that one. Then we have negative 1 and 1, and here we have 1/2. This line goes through these 2 points. But this line here, it goes through the origin. And we can check that when x1 is 1, then x2 is, if x1 is 1, x2 is 2. Then we have a point 1, 2. We have this line. And we can check that these two lines are parallel. Then in this case, we have no solution. This is the case when we have two equations with two variables, and we're going to see that for every linear system, like we defined before, we're going to have the same situation. We are either going to have infinitely many solutions, or we're going to have exactly one solution, or we're going to have no solution. I think that I would like to stop here.